Here now is Chief Meteorologist Tom Sorrells with Talk to Tom, sponsored by Greenway Dodge.
The planet is getting hotter, and Florida's no exception. New numbers show we are reaching new records. We will take a closer look at that issue and what's to blame. I'm Chief Meteorologist Tom Sorrells from the powerful WKMG. Thank you so much for tuning in to Talk to Tom. We love having you here. We're going to dig deeper into that, but before we do, I want to take your questions. Our first question of the day comes to us from our friend, Ntanda. Hey, Ntanda, what's up?
What is a controversy over pollution? Because some folks will argue that what is being said by those who are against pollution is not necessarily as dangerous as it seems to be presented. So there is a kind of dramatization of the situation so that it becomes difficult for countries to decide whether you protect the environment or whether you develop your country by using, natural resources. So again, I think it is somehow tied to issues of weather, nature and so on, environment. And I think it could still fall in your domain. How do you answer that?
Okay, that's a great question, Ntanda, and I appreciate it. I don't know where you're from or what country you're worried about, but we need to worry about everyone, and we need to worry about pollution. When you say pollution, my guess is you mean air pollution. And overall air pollution is our greatest concern. When it comes to pollution, really, drinking water, clean drinking water, and clean air are the two things that we really have a hard time doing without. So when it comes to pollution, I address mostly air pollution and not the water, even though the water is of grave concern to me. We talk a lot about the plastic in the ocean, and we talk a lot about fresh water and clear drinking water. And I personally don't have a controversial issue or stance on the pollution. I know what's going on, and I see what's going on. I think maybe you're hearing from some folks when you say don't agree with the scientists or don't agree that pollution is a problem. I think those are what we would term climate deniers, and it's a hot button issue. I know that it is. And when I start talking about it, I know it angers a lot of folks. But the truth is, in our lifetime, and I'm not saying you're as old as I am, but in our lifetime, the atmosphere has become hotter, and carbon is the reason, a proven reason. We've known that carbon in the atmosphere produces a warmer atmosphere. That's not a new idea. It is not a new thought. We've known for hundreds of years, since the 1700s, that carbon into any atmosphere traps heat. Scientists knew it in the 1700s. We've also known that the parts per million of carbon in the atmosphere have been on the rise. I forget what the number is, but back in the 60s, when I was born, mid to late 60s, the number of parts per million of carbon in the atmosphere was much lower than it is today. And every day in Hawaii, at the top of a mountain, scientists there measure the current parts per million of carbon. And we know that it's on the increase, and we know that it's trapping heat, and we know for certain that the temperature is rising at an unprecedented rate. Some people argue, if you go back in historical times through how far back we can research through ice cores and through the earth, that there have been hotter times and carbon has been higher. Yes, that is all true, but that all predates humanity. In the last 6,000 years, it has never warmed this rapidly, ever. And so it's kind of a no-brainer or an easy conclusion to come to that we are warming rapidly, and air pollution by carbon is the reason for that. Now, if you're talking about other pollutants like pollutants in the ocean, trying to get the plastic out of the water, trying to get that big Pacific area that circles around out there in the Pacific, trying to clean all that up, I am all about clean oceans as well. But you were talking about the developing countries, and yes, it is kind of unfair of us as developed countries to suddenly say to countries that are trying to catch up and develop economically now that we use carbon energy to do it, and now you can't. But that's going to be the future. The future is not going to be carbon energy after about 20 or 30 years from now. We're making the turn to electric vehicles. People will argue with you that China is a great polluter, and they are. India, same thing. But they are also doing a better job of living for the future and developing their latest houses to be green and clean in the future. And they're also switching to nuclear. which I think is going to be a big deal, a big switch in the future. Okay, I could go on and on about that, but we have other questions. I would like to get in touch with you if you want to ask me about that. Send me an email, tsorrells@wkmg.com, and I'd love to talk to you about it. All right, let's hear from our friend, London. Hey, London, what is up?
How are you able to predict the weather?
How old is London? How adorable is she? All right, let's talk about predicting the weather, London. I've talked about this a lot on Talk to Tom, but I realize you're probably not a full-time viewer because you're probably in school a lot. The way we predict the weather is twofold. There's what we call observational weather and numerical weather prediction. Two ways. And we combine those to come up with your forecast. Observational weather basically is the temperature, the wind speed and direction. What's going on outside, we look at it, and we look at it through radar, and we observe what's going on. Weather tends to be the same day to day until the changes start to occur. We can see the cold front coming. We observe it. Now, to forecast what it's going to do when it gets here, how much we're going to drop, that becomes numerical weather prediction. So we have what we call models that use algorithms to figure out what's going on. We put our numbers in based on mathematical equations that scientists have come up with through the last 100 years of forecasting. Our computer spits out a number, and I can look at that number. If the overnight low is projected to be 38, I can say, wow, I don't believe it's going to be 38 quite. I bet we only dropped about 40 or 42. That becomes my forecast. Through observing where the rain is, where the cold front is, what the temperatures are, and then looking at the models, that's how I make my forecast. I hope that answered your question. If it didn't, again, tsorrells@wkmg.com, and I'll talk to you about it more. Sean Wilder's here.
When does it snow in Florida?
Yeah, they told me the snow question was coming. All right, Sean, let's talk about that. When does it snow in Florida? Well, in the Panhandle, it snows every few years. They get some snow and ice in the Panhandle because the weather there is quite different from here. But here in Central Florida, we normally are able to come up with a snow situation with a particular setup. And normally it is when a cold front comes all the way down, an Arctic blast comes in, and then the front stalls just to the south of us, and a pocket of low pressure will form on the front just off the east coast of the US of A. And the backside of that low, throwing moisture on land, is our normal setup for snow here in Florida, or graupel, or pellets of ice that are not hailstones but sleet. That's normally what we get here in Florida, is that kind of weather. That's the weather pattern. Big Arctic outbreak, and then a low develops off the shore that pushes moisture from the ocean over that cold air, and we get snow. That hardly ever happens. I don't think it's happened in the metro, Seminole and Orange County, since January the 9th of 2010. So, all right, next question. This one is from Leah. Go, Leah.
How do I get my name as a hurricane name?
Oh, good question, Leah. Listen, I don't name the hurricanes, and neither does the National Weather Service, and neither does NOAA. You know, our Hurricane Center folks down in Miami, Florida, they don't get to name the hurricanes either. The hurricanes are named by the World Meteorological Organization, and they use the reoccurring list of names that they have. They repeat them every 6 years. So if you're trying to get your name on the list, I would say you should write your name to the World Meteorological Organization over in Switzerland, where they're located. They're part of the UN. So there you go. All right, next one up, our friend Lola. Talk to me, Lola.
How do tornadoes form?
Okay, Lola, I love your name. It was my mother's name and my grandmother's name, Lola. Tornadoes form during a thunderstorm when winds aloft are speeding along and you get unstable air going. You get the wind aloft going rapidly and warm air rising up underneath it, and the air starts to rotate. Sometimes you get a roll cloud going up there that will spin down to the ground. More often than not, you get warm air rushing up from the bottom that is not going as fast in a forward motion as the top of the storm, and it starts to make it twist. So there's your answer. Big convection, big thunderstorm going. That is normally how we get a tornado to form. We also get tornadoes to form by colliding sea breezes here in Central Florida, where they hit and start to rotate. There you go. Great question, though. Hey, thank you for your questions. Remember, if you have a question and you'd like me to answer it, just submit it at clickorlando.com/talk to Tom. And please stick around as we talk about what is causing our planet to heat up so much. 2023 was one for the record books. We had the hottest summer and one of the warmest winters. So what's on tap for 2024? Thanks for tuning in with us. I'm Chief Meteorologist Tom Sorrells. It is Talk to Tom time. Today, we're going to talk about all that heat with our friend Karen Gleason. She is the Monitoring Section Chief at NOAA NCEI. Karen, welcome to Talk to Tom. How are you today?
I'm great. Thank you for having me.
Thank you so much for taking time out of your schedule to join us. We really do appreciate it. I love all the kind of work that you do. Let's talk about global temperatures and how hot the Earth was last year.
Yeah, so in 2023, to many people's surprise, we saw not only record heat globally, but by a significant margin compared to the prior record. So in 2023, the globe measured 2.12 degrees Fahrenheit above the average, and that is not only the highest, but the next highest, which was the former record year, was 2016, and we bested that amount by over 1/4 degree Fahrenheit, which is really unheard of in the history of the global climate record. Every month of 2023 globally had at least a month 7th warmest or warmer, and June through December, they each had their warmest month on record. July was likely the warmest of any month on record from 1850 through to the present. And we saw the September temperatures were so warm, they were almost 3 degrees Fahrenheit above the long-term average. And that is the largest positive temperature anomaly for any month on record for the globe. So there are a lot of superlatives that occurred in 2023. And when we started the year this time last year, we were saying that there was likely only in single digits, like 5 to 8% chance that 2023 would be the warmest year on record. But keep in mind, we were coming off of a La Nina. We were still in a La Nina in the winter of last year. And as 2023 kind of got going, that became ENSO neutral pretty quickly. So we transitioned from having cooler waters in the equatorial Pacific to warmer waters by late spring, early summer. And it just was a firestorm after that, as far as both ocean and land heat across the globe.
Okay, I'll come back to that El Nino thing in just a moment. First, let's talk about Florida, because here in Florida, I live in Orlando. The market you're talking to is from Flagler County, Palm Coast, all the way down past the Space Coast, inland to Ocala and almost to Lakeland. So it's a big geographical market.
Yes.
We're really warm. We are subtropical. Every time I talk about it's hotter than normal, people go, it's Florida, but that's not really true. Talk about Florida for a moment. How hot were things for us in Florida?
Yeah, so in 2023, looking at the year as a whole, it ranked as the second warmest year on record. The warmest year on record is 2015. And it's not by much. We're talking by a 1/10 of a degree Fahrenheit. So if you're looking at photo finishes, it's like a nose ahead of we're a nose behind 2015 in that photo finish. But what we're seeing in both Florida as well as in Orlando proper is that in the last 9 years, you've experienced the warmest 9 years on record since 1895. So looking at the Florida temperature time series, the last 9 years, the warmest on record. And that's not just for average temperatures, but that's overnight temperatures, which tend to be the low temperatures, and high temperatures, which are daytime temperatures. But we do notice that in Florida, overnight temperatures are warming at a faster rate than daytime temperatures. And a large reason for that is the increased amount of moisture in the atmosphere. For every 1 degree Fahrenheit of increase in temperature that you have, the atmosphere can hold an additional 4% water vapor, more water vapor. And water vapor, as many of us know, acts as an insulator. So whether it's at night, you might have more cloud cover, you might have more precipitation or more rainfall, and moisture tends to hold in heat. It doesn't let it escape at night. So night times are not cooling off as much as they would have, say, 2, 3, 4, 5 decades ago.
Let's talk about NOAA and how you actually study these things. I have a hard time explaining to people what the global temperature is. They're like, and like the globe, like you just said in the beginning, we're up like a degree, 2.1 degrees over what we were How does NOAA come up with that? How do you figure that? Explain that if you can in 25 words or less for old Tom.
Yeah, this is going to be tricky because
Yeah, it
it's
is.
very technical. So we actually have coverage to some extent around the entire globe. We do have land-based, ocean-based. We have buoys, we have ships, we have lots of instruments. It's all instrument-based. So we take all of that instrumental and that measured data from the surface, ocean and land. And like I said, we have some fancy programs that kind of compile all of that together, and they provide for each grid box a departure from the 20th century average. And we average all of those numbers together. We area weight them because the different grid boxes are different sizes depending on the latitude. And again, really complex. And I've probably already talked for about 50 or 60 seconds now. But that overall average, then we are able to keep in our database. And we have data records from all around the world from the mid 1800s and even before that we can tap into, and we can make comparisons for what's happening now to what happened back then and everywhere in between. So that's in a nutshell how we compute that number. But like I said, we've never seen a number quite this high, and not even close. This wasn't a photo finish. This was a year that was definitely well ahead of any other horse in the race.
There we go. All right, well, let's talk about that. When you say it's ahead of anything we've ever seen before, one of those sayings they always do in the weather world is, wow, we've never seen anything like this before. But we've had warm years before. So to your description, have we seen anything like this before? Have we seen a year that blew everybody away and then came back closer to normal?
You know, it's interesting because not only was this a year unlike really any other year that we've monitored on record, even the climate experts of the world have kind of all said at one point in time since really late summer or fall, this is warmer than even what we thought might happen. So this all kind of it comes back to looking at El Nino and ENSO, the El Nino Southern Oscillation phenomenon in the equatorial Pacific, and what that does to global temperatures. We know that there's a direct correlation between La Nina, or the cooling of those waters, suppressing global temperatures, and El Nino, and especially if it's a really strong one like what we had in 23 and what we're still in right now in early 24, that tends to enhance temperatures. And so there's a lot of talk about what are the drivers. Why is this year so, or when I say this year, I mean 2023. Why is 2023 so different from everything else that we've seen? And we have a good, dozen or so El Nino years and strong El Nino years that, we can look back on and say, how did global ocean and land temperatures respond? And this really kind of stands out as kind of being by itself. So it's not really understood why it got so warm so fast and why it stayed really, really warm. It just really amplified through the second half of 2023.
Okay, last question, because we're running over. I could talk to you all day, so I'm sorry I have to make this the last question.
That's all right.
We're talking about 2024. Do you expect it to still be hotter? You do, yes. You don't think it'll be 2023, but you think it will be warm with El Nino?
So this is interesting. So here at NOAA and CEI, we have a temperature ranking outlook product, a tool that we use. It is not a forecast tool as like a model looks forward. This tool looks backwards at all of the historical data that we have. Long story short, this temperature ranking outlook says there is a 1 in 3 chance, so about a 33% chance that 2024 will be warmer than 2023, and a 99% chance that 2024 will be one of the warmest 5 years on record. So the takeaway here is we do not anticipate 24 being a cool year. It could even surpass 23. But I will tell you that the Climate Prediction Center, one of our sister organizations here in NOAA, they are anticipating a transition to ENSO neutral in the late spring, early summer. So we're starting out really warm, still in a strong El Nino. Temperatures are still amplified. They're still really warm. And so we'll see. I mean, keep in mind, last year we predicted in the single digits the probability that 23 would be the warmest year. And here we are by a landslide. So we're saying 1 in 3 chance that 24 could exceed. Time will tell, and each month we'll get closer and closer to how the year will end up. We've got 12 laps in a race, and we'll be monitoring it very closely.
All right. Thank you so much, Karen. That is Karen Gleason, Section Chief of NOAA NCEI. Thank you so much for joining us on Talk to Tom.
Thank you for having me.
All right. Hey, if you at home have a question you'd like to be on Talk to Tom with, just go to clickorlando.com/Talk to Tom to submit it. You can download this podcast from wherever you get your podcast or watch anytime on News 6 Plus.